Hello and good afternoon, and welcome to this video tutorial which is going to build upon the previous video tutorials from the Cisco Networking Academy Route version 7 lab 7-3, where we had talked about the International Travel Agency being multi-home to a single service provider. And what we're going to do here is we're going to try to make this even more realistic by adding in a second and third service provider to the topology. However, what we have now is we have the International Travel Agency over here on the right-hand side of the screen is now single-homed, but to dual providers. And this is probably, in a medium to large size corporation, probably a little more realistic, where we've got two individual routers, and each of those routers is connected to a different service provider to ensure that if for whatever reason our connectivity with one of the service providers, maybe Sprint, goes down, that we can still connect through with AT&T. And so what we're really doing here is we're going to pull together all of the concepts that we've seen in Chapter 7. We're going to look at the next hop self configuration. We're going to look at the local preference configuration to control our outbound traffic. We're going to take a look at what happens when we see those RIB failures. We're going to set the MED, the multi-exit discriminator, to try to influence our incoming traffic. And we're actually going to get a great opportunity to look at the optional non-transitive nature of the MED attribute and how it does not go beyond the AS, the neighboring AS with which we set it. Then we're also going to look at AS path prepending. And finally, we're going to take a look and build upon the default originate setup that we did in one of the previous labs, I believe maybe 7.1 or 7.2, where we did the default originate. However, here we're going to build upon that with a distribute list to make it, again, even more realistic, because when we set up the default originate, what we saw was, sure, we get the default route, but without a distribute list in there, we are still also getting all of the routes from the provider that we're paired with. And so we're going to go ahead and take a look at that as well. All right, so let's go ahead and jump in. The base configuration is done. As you can see here, I'm running EIGRP between router 6 and router 7 to go ahead and facilitate my iBGP connectivity. So if I was in user exec, we'll go to privilege exec here. If I were to say ping, and again, I'm on Santa Rosa 01, and so I'm going to ping the loopback address of Santa Rosa 02, which is 172.16.32.1. You can see we've got connectivity there. If I were to show you show run section EIGRP, and as you can see, actually, I didn't use AS64555. We just threw EIGRP1 in there. So again, very crude, straightforward setup for EIGRP. Basically, the network statement is going to make sure that we're running EIGRP between all of our interfaces here, the transit network as well as the loopback interfaces. And the configuration is identical over on Santa Rosa 02. But again, we're not interested in our EIGRP as we are so much the BGP configuration. So let's go ahead and go into global config, and let's set up our BGP config on router Santa Rosa 01. So I'm going to say router BGP 555, and that's our autonomous system number. I'm going to go ahead and log neighbor changes, and I'm going to set my router ID. And I'm just going to use the actual number of the router, in this case 6, so we'll just say it's 6.6.6.6. All right, so I want to go ahead and configure my peering with my neighbor, and I'm going to use the loopback address of Santa Rosa 02. Now, this is an iBGP peering because these neighbors are in the same autonomous system. All right, and then we're going to say neighbor 172.16.32.1 update source loopback 0. And so a quick note on the update source. So the reason that I'm using the loopback 0 here is because realistically I could have multiple connections or multiple paths to get from router 6 over to the loopback of router 7. And vice versa, router 7 would have multiple paths to get to my loopback address. So on router 6, right, Santa Rosa 01, I'm telling it that when you set your neighbor relationship or your adjacency up with router 7, that when I send packets over, right, BGP packets over, that I'm going to be sourcing them from my loopback 0 address. Because if I don't set it to the loopback 0 address with this update source loopback 0 command, what happens is when it goes out, it's going to use the outgoing interface as the update source, right? So in this case, 172.16.1.1. Well, if that link went down for whatever reason, and let's say that I have another path somehow maybe on my IGP, excuse me, you know, back here in my distro area, I've got my switches and I could be with a bow tie setup here. If I have another path to get to this loopback coming maybe this way, right, then everything is fine. I can still reach this loopback address from which the packets are being sourced. If I don't use the loopback and I have multiple paths, when this goes down, that's it. I'm down, even though I could have maintained that adjacency via a different path. And so that's why we set the update source, when possible, to the loopback address. And you're going to see when I set this connection up here and when I set this connection up here, we don't do that because, again, it's a point-to-point connection. We've only got one path to get to that transit network address, right? So that's why you would use the loopback, excuse me, the update source loopback 0. All right, let me go ahead and clear this layer real quick here. All right, there we go. So we do the update source loopback 0. Now I'm going to set up my BGP configuration for my peering with my service provider. So the International Travel Agency, and we're talking about the Santa Rosa, California office here, has a peering with Sprint, which is Autonomous System 2050, and we have a peering with AT&T Autonomous System 7018. So I'm going to say neighbor 192.168.1.1. Now the remote AS for Sprint will be 2050, and this is an eBGP peering. And when we take a look at the show BGP IPv4 unicast, we'll be able excuse me, we'll be able to see that. And when I take a look at the if you were to do the show IP BGP, we'll see much the same thing. Now again, here I'm not setting the update source to be the loopback 0 address because we've got, it's a point-to-point peering. If my link goes down with Sprint, then that's it. There's no other way for Sprint to get to me, right? So we're going to leave it the way it is there. So let's take a look at our BGP section. So show run section BGP, and let's see what we have so far. So we've got our router BGP 555, we've got the router ID, we've got our log neighbor changes, and then we have our neighbor statements. Final thing is, I'm going to go ahead and do a network statement for my loopback address. So we're going to say 172.16.64.0 with a mask of 255.255.255.0, right? So let's jump over to Santa Rosa 02. We'll go from user exec to privilege exec into global config. And let's make sure we've got connectivity over to the loopback address 172.16.64.1. And we do. And again, that's via EIGRP. So if I say do show IP route, you'll see that my route and how I know how to get over to the 172.16.64 is via EIGRP. Oops, sorry. That's what that D stands for there, right? For dual, the diffusing update algorithm. And my outgoing interface is going to be serial 010. So from Santa Rosa 02's perspective, I'm going to go this way, right? And I'm learning that route via EIGRP. So let's go ahead, say router BGP 5555. We're going to say BGP log neighbor changes. BGP router ID will simply be 7777. And let's do our IBGP peering statements here for 172.16.64.1. And the remote AS is the same as ours, 555. And then let's get our update source loopback 0 in there. All right, so, and there it is. I was just about to say we should see our BGP adjacency come up and form, and so there it is. So now we have our IBGP adjacency formed here. Let me go ahead and do a do show BGP IPv4 unicast. And as you can see, and this is what we want to take a look at right away, as you can see, we are learning the one route from from Santa Rosa 01. And what route is it that we see in the BGP table? Well, it's to that 172.16.64. Now, you'll notice we have the R here. Typically, you should see an asterisk, right, meaning that it's a valid route. The second column, or the second character, I should say, the greater than sign, and if you look right up here, you can see the legend. The second character means that it's the best path, right? So that's been selected as best. The third character in will be either an I, and it's not these characters here, right? So this origin code, the origin code is at the end, and sometimes this can be confusing, right? So the origin code is going to be down here at the end. These characters here, the third character, you could see an I, and that indicates that it was learned, excuse me, that it was learned via an IGP, right? So again, that third character in, or I'm sorry, for IBGP, it means it was learned via IBGP, right? Because we have this IBGP peering. How am I learning about this? Well, I'm learning about it from my IBGP peering with Santa Rosa 01. However, I have this R here, which stands for rib failure. Where's the R at? There it is. Stands for a rib failure, which means that I'm not going to install this. It's not going to go into the routing table as a BGP route. So if I were to say do show IP route, you can see that the rib failure means that that route is not getting installed into the routing table as a BGP route. As you can see, we have no BGP routes right now. And the reason for this is because we have a route with a better administrative distance. Now, we're actually, when we get the eBGP peerings up, we're going to see that the eBGP routes that we learn, eBGP has an administrative distance of 20. However, IBGP has an administrative distance of 200. So, with two routes to the same destination, with two different routing protocols, I can't compare the metrics, right? Because it's apples and oranges. So if I was looking at a route to the same destination and I had learned it from EIGRP with an administrative distance of 90, OSPF with an administrative distance of 110, and IBGP with an administrative distance of 200, EIGRP is going to win out, right? And it did right here. So if I'm interested in learning, if I run this command again, show BGP IPv4 unicast, if I'm interested in learning how is it or why is it that I've got a rib failure here, Cisco iOS has a really nice command. I can say do show BGP rib failure, right? I put rib, but it's rib failure. And it'll actually tell me why this route is not getting installed into the routing table. And so here's my rib failure reason. As you can see, higher administrative distance, because the IBGP route has a higher administrative distance than the EIGRP route. And again, remember, it's in situations or scenarios like this where we have multiple routes from different routing protocols to the same destination prefix, because there's no way for Cisco iOS to say that the OSPF metric is equal to the EIGRP metric is equal to the BGP metric, because think about it. At the end of the day, BGP really doesn't use metrics, does it? It uses attributes. So again, you're comparing apples and oranges, and the only way that Cisco iOS has to differentiate between which path it's going to select, that's where your administrative distance comes into play. So I have a BGP route to this destination prefix and an EIGRP route to the destination prefix. And because the administrative distance of EIGRP is 90 and the administrative distance of IBGP is 200, this route gets installed into the routing table. And again, do show BGP rib failure tells us the reason for the failure is that my BGP route has a higher administrative distance than the route that is currently in the routing table. Therefore, we're going to see a rib failure there. Now, we're going to see the same thing. Let's take a look at our do show run section BGP. I think we need a network statement, and we do. So we're going to go ahead and originate the loopback address as well. 172 on this side for Santa Rosa 02, 64.0 with a mask of /24. So if I were to go over now to Santa Rosa 01 and say do show BGP IPv4 unicast, excuse me, you can see that we see the route here with a local preference, I'm sorry, with a next hop of 0000 over to, and I'm waiting here, I may have to kick it. So what we're seeing right now, so we see the route, that's the route to ourselves, and the way that we know, or to our loopback address, the way that we know that this is locally originated is the next hop is the quad zeros. That means us. So I'm trying to be patient here, and I could force the update, and I think I might have to. All right, I'm going to be impatient about this. So I'm going to come over here, I'm going to say do clear, do clear IP BGP star out. And now if I hustle back over to Santa Rosa 01, and we should be picking up, and let's see, all right, so I've got it from 64. Did I? Oh, I'm sorry. I apologize. I had a typo in here. Okay. Do show run section BGP, and I put in the wrong address, didn't I? I did. I apologize. So let's get this out of here. I wanted 32. I was wondering why it didn't show up there. All right. So we want network 172.16.32.0, which is actually the loopback subnet that we own. 255.255.255.0. So there we go. So now if I were to take a look at the BGP routing table, so there we go, right? So we see our rib failure. Let me scoot back over to Santa Rosa 01, where we see what I was hoping we would see, which is this is our local route here on Santa Rosa 01, or our local rib entry. And as you can see, you know that it's local because of the quad zeros. And so we see the same thing with the rib failure here, right? Because, again, remember, EIGRP is running between the two routers. And so the EIGRP, if I said do show BGP rib failure, again, we don't install the BGP route into the routing table because of the higher administrative distance for IBGP learned routes. All right, so do show run section BGP. Okay, so we're good there, and we've got the eBGP peering set up. Let's go ahead now on Santa Rosa 02, and we're going to add in the neighbor statement for our eBGP peering with AT&T. So this is going to be on 192.168.1.1, and the remote AS for AT&T is going to be 7018. And again, we're not going to put that update source loopback 0 because in the scenario that we have here, there's only one path for us to get to that internal loopback address. So do show run section BGP, and there we go. Very similar to the Santa Rosa 01 configuration, with the major difference being that our peering is to a different autonomous system. All right, so now let's jump in on the provider routers here. We're going to jump onto the Sprint ISP router and go from user exec to privilege exec into global config, and we're going to say router BGP 2050 because that's the Sprint autonomous system number. We're going to say log, oops, we're going to say log BGP, I'm sorry, BGP log neighbor changes, and then BGP router ID, and that is going to be 4.4.4.4. And let's go ahead and set up our peerings here. So I'm going to say neighbor 192.168.1.6, double check that, and the remote AS is going to be 555. And we should see a peering pop up here shortly. I'm going to go ahead while it's waiting for the scanner, the BGP scan process. I'm going to go ahead and say neighbor, and we're going to set up our peering with Verizon 50.50.50.1. And the remote AS over on the Verizon side is 701. Excuse me. All right, now I'm also going to originate, for now, I'm going to originate this loopback address. So we're going to say network 10.1.1.0 with a mask of 255, 255, 255.0. And as you can see, our adjacency has come up there with Verizon. So if I were to say do show BGP IPv4 unicast, you can see that we are learning some routes from AS701, right? And we have a RIB failure here. We'll take a look at this because this is a little different, right? There is no routing protocol running between Sprint and Verizon. It's simply a point-to-point connection. So when I say do show IP route, why do we have that RIB failure? Well, what is my route to the 50-50-50 network? It is directly connected, right? Directly connected, which is an administrative distance of 0, which is always going to be lower than the eBGP, which would be 20, or iBGP, which would be 200. So again, if I say do show BGP RIB failure, we have a higher administrative distance, and that is why we see that RIB failure message, and that's why it's not getting entered into the routing table. All right, so we're learning about the 70-70-70 from Autonomous System 701, which is Verizon. We're learning about the 50-50-50 and the 32-32-32, which is the loopback address up here, which is being originated off of the Juniper router, and the 10.1.1.1, right, which is local to us. However, we don't see our peering right now. Do show run section BGP. We don't see our peering here. Router BGP 2050. We have our neighbor statement in there for 192.168.1.6, remote AS 5555, and it hasn't come up yet. So if I were to say do show BGP IPv4 unicast, unicast neighbors. All right, so there is our eBGP peering, right? Shows an external link over to the router with the router ID of 32.32.32.32. That's our Verizon router that we're peered with. This is my neighbor's IP. And the question is, do we see a peering here with 192.168.1.6? Well, we do. So it just didn't push a message up to our console. So you can see that the neighbor is 192.168.1.6. We've got the remote AS. However, it's not picking up the router ID. It does see that it's an external link, but we're not sending or receiving any messages here, right? So if I were to say do show BGP IPv4 unicast summary, what's the difference? So you can see there's a significant difference here, right? So the uptime, here we've been up for 3 minutes and 11 seconds. Over here, this relationship has never come up, right? And we're stuck in the idle state. Here, we've received 4 prefixes from Verizon, the Verizon Autonomous System 701, and we've got none here. Now, I'm running 15.3 code on these routers, and I've noticed that sometimes there's a bug where, for whatever reason, it won't bring up the peering, and I've actually had to recycle the router. So I'm going to go ahead and leave this here for a second. We'll move over to AT&T and set up that peering over there with the Santa Rosa O2. But I'm going to say do clear IP BGP star to see if maybe I can give it a kick here. And it's bringing back the adjacency with Verizon, the Verizon peering, but it's still not peering with 192.168.1.6. And that is the right IP address. Let me make sure. Do ping 192.168.1.6. And I should have connectivity because it's right there. We're directly connected. So let's scoot over to AT&T. Let's see if we have the same problem over with AT&T. All right, so here's my AT&T ISP. We're going to go from user exec to privilege exec, into global config at some point. So we'll get into global config here. And let's jump right in. So router BGP and the AS over here is going to be 7018. And I'm going to say BGP log neighbor changes, and then I'm going to set my router ID to, what am I? I'm 1.1.1.1. So now let's go ahead and first configure our eBGP peering with the International Travel Agency Santa Rosa O2 router. So I'm going to say neighbor 192.168.1.2, and the remote AS is going to be 555. And then I'm going to say neighbor 192.168, oops, sorry, not 192. We're going to go with the Verizon peering now, 70.70.70.1. And the remote AS with Verizon is 701. And let me go ahead for right now, and just so we've got some talking points here, let's originate the 10.2.2.0. We're going to advertise that loopback address, and there you can see the Verizon peering is up. So we've got 10.2.2.2 with a mask of 255.255.255.0. So if I were to say do show BGP IPv4 summary, unicast summary, you can see that the peering actually came up, right? We've got both of our peerings. We had the peering pop up here and the peering pop up here. You can see I've received 5 prefixes from AT&T and 2 prefixes from the Santa Rosa O2 router. So if I were to say do show run section BGP, here's what my BGP config looks like right now. If I say do show BGP IPv4 unicast, you can see we have a single rib failure, right? And this is to be expected again because that 70.70.70.0 subnet is directly connected, right? And so that directly connected is going to have a lower administrative distance. Therefore, BGP is not going to win this one. But let's take a look at the routes that we are learning. So you can see we've learned about the loopback address of the Sprint router over here, 10.1.1.1.1. And it came, the originating autonomous system was 2050, which is where Sprint sits. And then it came through autonomous system 701, and then it arrived at us. So we've learned about the loopback address on the Verizon routers. And as you can see here, we have even learned from our eBGP peering with Santa Rosa O2, I've learned about the 2 routes which are for the loopback interfaces here, right? And again, coming from autonomous system 555. My next hop, well, my eBGP peering is with Santa Rosa O2, and so that shows as my next hop. So now I'm going to have to come back. We're going to have to deal here with Sprint, who does not seem to want to cooperate. So let's take a look again and see if it's come up. Oops, sorry, not the ping. Unicast summary, and again it shows that the peering is not up. Let me say do show run. Let me make sure section BGP that I don't have a typo of some kind in here. neighbor 192.168.1.6 remote AS555. Yeah, so here's what I'm going to do. I'm going to type in. We're going to save our config. I'm actually going to pause here shortly. I'm going to reload this router because the 15.3 code, I've had this happen multiple times with BGP configurations where I have to actually reload the router in order to bring it back. So I'm going to pause shortly, and should be no more than 3 minutes, and I will be right back. All right, and as you can see, one of the toughest problems to troubleshoot is one that doesn't exist. So on Santa Rosa 01, I reloaded the router and the adjacency didn't come back up, and I'm like, wait a second, there's no way I put in the wrong neighbor statement on Santa Rosa 01, and sure enough, I did, and there it is. So let's go ahead and fix this here. Copy and paste. And the neighbor is actually 192.168.1.5 remote AS 2050. And this should sort things out, and we should have our adjacency pop up here, and there we go. Yeah, I've had, like I said, I've had it hang a number of times with the 15.3 code. And, but yes, that was definitely not a code issue right there. So now when I do the summary, you can see that we're up. We've got prefixes being exchanged. If I were to say show BGP IPv4 unicast, right? So we've got some nice output here to take a look at. As you can see, the Sprint ISP is learning multiple paths, right? Learning about multiple paths for some networks here. So let's take a look at this first one. So it's learning about the 172.16.32.0. So this is the loopback network on Santa Rosa 02. And Sprint is learning about that over here. So how is it learning about it? Well, it's getting it from two sources. The first source is from its directly connected neighbor, Santa Rosa 01. However, it's also learning about it with having it originate off of Santa Rosa 02 coming through AT&T and then through Verizon, right, with a next hop of 50-50-51, because this is the Verizon path that it would take. So we have two routes. So why did it choose this route, the next hop being the directly connected neighbor, versus the Verizon hop, going through the Verizon AS? Well, again, there really is no metric per se. It's the path attribute, right? And the AS path is one of the path attributes that BGP looks at when it determines which route it's going to select as best. And here, and we're actually going to see this when we do the, we're going to do some AS path prepending from the International Travel Agency perspective. You can see here that the AS path length of this prefix and route is 2 autonomous systems shorter than this path to the prefix. So it has selected this one. And again, same thing here in getting to the loopback address of Santa Rosa 01. It's only one autonomous system going to the next hop of 192.168.1.6, as opposed to jumping through 3 autonomous systems to go that route. All right, so now what we're going to take a look at is the next hop self feature. So we're going to jump over here to Santa Rosa 01. Let me save my config. So we'll jump over here to Santa Rosa 01. And remember, Santa Rosa 01, if I do a show IP route, Santa Rosa 01 has a number of BGP routes. It's got a number of directly connected routes, but does it know about the transit network here, the 192.168.1.0? Well, you can see that I've got 192.168.1.0/24. It's subnetted, and here are the different subnets. But is there a subnet here for this transit network? So would I know how to ping 192.168.1.1? And the answer is no, right? I don't know how to ping 192.168.1.1. I don't have a route to get to 192.168.1.1. How about, can I ping 192.168.1.2, and again, I'm actually pinging the interface which is on router 7 to which I'm directly connected. And again, the answer is no, because I do not know how to get here. I don't have a route to get over to this network. And so if I'm learning, if I were to say show BGP IPv4 unicast, so the routes that I'm learning here, right, as you can see, I've got multiple paths to some of these routes. If the next hop is not reachable by me, right, then not only am I not going to be able to get there, BGP is going to say, hey, I'm sorry, I can't put that route in the routing table. So I'm going to go ahead and simulate that right now. So if I were to go to the AT&T router and go into interface fast Ethernet 00, and I'm going to cut off that interface right now, and it's also going to take down that BGP peering. So what we're doing right now is right here we're saying that this has just gone down, right? And this becomes important. I'm simulating it, but if for whatever reason further down the stream this happened, let's take a look at the impact of that now on Santa Rosa 01. So whereas before I was learning, I had all these multiple paths, right? And you can see my next hop here, 192.168.1.1, right? The problem is I didn't know how to get there. So how do I now get to the 10.2.2.0 subnet? How do I get to that loopback interface here, right? So take a look. I have a route for it in the BGP routing table, right? Is it valid? It is a valid route, right? And this is the next hop I need to get to. However, and I've learned about it from iBGP, however, it's not getting installed, right? It's not being put in as best. So it's not going to go into the routing table. So let's take a look. If I say show IP route on Santa Rosa 01, is that route to the 10.2.2.2 in my routing table? It's not, because if BGP can't recursively get to the next hop, if it doesn't know how to get to that next hop, it's not going to put that route into the routing table. And therefore, even though I have a legitimate and valid path to get there, right? I mean, this is valid. I could get there if I knew how to get to the next hop. And so this is where the next hop self comes into play. And the key thing with next hop self is that what we're really saying is, and I'm going to go ahead and set it up on the International Travel Agency, is for iBGP, there's some rules here, right? So when an eBGP route comes in, right, for this 10.2.2.2, he comes in as an eBGP route. The next hop of that route does not get changed when the eBGP route that R7 Santa Rosa 02 learned about gets shared with Santa Rosa 01. So it comes in with the next hop of the outgoing interface of router 1, which is that 192.168.1.1. Santa Rosa 02 receives that route and says, hey, great, thanks. Let me share that with my iBGP peers. So he shares it with router 6. However, the rule is that eBGP learned routes, the next hop does not get modified. So I learn about it this way. This is the next hop, right? 192.168.1.1. I share that route with router 6 and say, hey, I've learned about this network over here with my eBGP peering, and for you to get there, router 6, you just need to go to 192.168.1.1. So you can see the problem, right? And it would be the same problem in the opposite direction. So this 10.1.1.1 here on router 4 from Sprint, Santa Rosa 01 is going to learn about that route. It's an eBGP learned route. So the next hop is going to be set to 192.168.1.5. It's going to come into Santa Rosa 01. Santa Rosa 01 is going to do exactly what a good iBGP peer would do. He's going to share that advertisement with his iBGP peer, Santa Rosa 02. And he's going to tell Santa Rosa 02, hey, to get to the 10.1.1.1, you just need to make sure you can get to the next hop, 192.168.1. And I'm going to get the IP right here on the left-hand side, .5. So let's take a look. Let's see if Santa Rosa 02 actually sees that the same way. So if I were to say do show BGP IPv4 unicast, do I have a route to get to 10.1.1.1 in my BGP table? I do, right? Take a look at this. And this looks, it's the exact same problem, right? And this is one of the subtleties of iBGP, is that when it's learning, and you could say eBGP as well, so that when I'm learning an eBGP route, right, if I pass that route along, and in this instance we're passing it along to eBGP or to an iBGP peer, the next hop address of an eBGP learned route does not change from where it originated. So the problem is here on Santa Rosa 02, he says, oh, if I could just get to 192.168.1.5. So how can we deal with this, right? Well, there's a couple things that we could do. So let's take a look at the non-preferred method to do this. So you may look at this and think, oh, okay, well then let's do this. All I really need to do is dump a route in here, right? So my route to get to 192.168.1.4/30, I just need to go out serial 010, right? So now let's run this, let's run this, and that is not what I wanted. Show BGP IPv4 unicast. Let's run this again. Did anything change? So here's the original statement, right? Now, here's the statement after I add in a static route. So we're fixed, right? So this should work great. So let's give it a try. So if I were to say ping 10.1.1.1 from my loopback address, which is Santa Rosa 02's, it works great, right? And that's a valid path. So what about a show IP route? Is that route now in my routing table as a BGP route? And it is, because again, BGP now knows, hey, this is how I'm going to get to the next hop. I can recursively figure out how to get there. Therefore, it's a valid eBGP route. And you can tell right here it's eBGP because the administrative distance is 20, right? And this is an iBGP learned route because the administrative distance is 200. All right, do you see that? So eBGP learned route, I'm sorry, I'm going backwards. iBGP learned route because router 6 is sharing it with me, so I'm learning about it via iBGP. So the administrative distance is going to be 200. I apologize there. I was crossed these up. And then the eBGP learned route, which is the 10.222 over here, I've learned about it from my eBGP peer, AT&T. So the administrative distance is 20. Again, 200 for iBGP, 20 for eBGP. Now, you may be asking yourself, okay, well, what happens when there's 50 routes over here that I need to pick up and we've got the static routing statement? Well, the static routing statement is still going to work for the next hop, right? Because when we put it in there, we simply put it in there saying, hey, my route to get here, which is going to be, this network here would be the next hop for all routes, eBGP learned routes, that I'd be getting from Sprint. So this single static route would work fine. However, there's another way that we can deal with this, and a more preferred way, sort of a more elegant way to deal with this, and this is going to be the next hop self command. So I'm going to go into global config, and we're going to remove that static route. So when I remove that static route, if I were to say do show BGP IPv4 unicast, what happened to my entry for 10.1.1 or 10.1.1.0? It's gone because, again, I don't know how to get, Santa Rosa 02 does not know how to get to this next hop. So here's what we're going to do. So on Santa Rosa 01, let's jump over here to Santa Rosa 01. We're going to go into global config, router, BGP 555, do show run section BGP, and we want to look at our BGP configuration, right? So here's my neighbor statement for Santa Rosa 02. Well, this is what I'm going to do. I'm going to say neighbor 172.16.32.1 next hop self, right? So now let's relook at our BGP config. So now I have a next hop self statement in here for my peering, my iBGP peering. And again, this is only with Santa Rosa 02. So let's go to Santa Rosa 02 now and rerun this command. Now you'll notice it hasn't picked it up yet. I may need to force it. So let me go ahead and I'll do that now. So I'm just going to say do clear, clear IP BGP star out. Now we'll step back over here. I've got the next hop self configured, and take a look at what has changed, right? So we've got some interesting output here. So what we're seeing is this is now the best route, whereas before, right, I didn't know how to get here. I had no idea how to get to that next hop. So when I add the next hop self in on Santa Rosa 01, what that does is that signals my iBGP peers and tells them that for routes which you are learning from me, I am the next hop. So for eBGP routes that are coming in from Sprint through me that I'm sharing with you, I am the next hop. And specifically, my loopback is the next hop because this is how you know how to get to me. This is where our peering is at. Because again, if we were unable to peer on this address, this next hop would never work. So that's what next hop self says. Next hop self says that if I learn an eBGP route, when I share that route with my iBGP peers, I'm informing them that, hey, if you need to get to this eBGP route that you have learned from me, I am going to be your next hop because I know how to get there, right? And so this is the use of the next hop self. So if we were to go back, and let me clear this out here. If we were to go back, we're on Santa Rosa 02. If I went back to Santa Rosa 01 and said do show BGP IPv4 unicast, we still have that same problem here with that 10.2.2.2. And the problem is, again, Santa Rosa 01 does not know how to get here. Sure, I could put a static route in here. I could even throw this into the EIGRP routing protocol and say redistribute connected, right? And have it redistribute this. Or I could put a network statement in and have it advertise it. And then that would fix the problem. So if I were to come over here to Santa Rosa 02 and say router EIGRP1 and then say network 192.168.1.0 with a mask of, what is that, 30? Wildcard mask of 000.252, right? And then let's come back over to Santa Rosa 01. Has that solved my problem? It did. So we've seen a couple different ways to deal with this next hop issue. The first is I can throw a static route in there. Okay, that'll work. I could also throw it into my IGP, which in this case is EIGRP. I could throw it in there, and that's going to fix it as well. Again, I'd want to passive the serial 000 interface on Santa Rosa 02. I should have thrown that in there because I don't want it sending EIGRP hellos out to my service provider, right? So again, the first two, the static route and then having the IGP advertise it, not too elegant and definitely sort of not the recommended / best practice. So what would we do? We do the exact same thing. Let me pull this out of here, and we're going to say no network 192.168. So I'm going to do the same thing. Router BGP 555. We're going to say neighbor 192.168.64.1 next hop self. Oops. And I've got this. Do I have this backwards? Let me see here. Specify do show run section BGP. So I've got the remote AS neighbor. Oh, I'm sorry. 172.16.64.1. That would have been my problem. Next hop self. All right. So I throw the next hop self command in here. What does it look like now? Right? Very similar to Santa Rosa 01. So now if I go back to Santa Rosa 01 and rerun this command, and I may have to give it a little kick here. So do clear IP BGP star out. We hustle over to Santa Rosa 01, and that problem is solved. And so this is really the core of what the next hop self command or attribute is doing. I'm basically signaling my iBGP peers and letting them know that for eBGP routes that I have learned, that I have that I've advertised to you to tell you, hey, I know about this route and how to get there, and I've given you a next hop, I'm basically saying, for those routes, use me as your next hop, right? Because again, the rule of eBGP is that the next hop does not change from where that eBGP route originates. It's not going to get updated when I then reshare it, right, or re-advertise it to my iBGP peers. So you've got to do something, and next hop self is definitely the preferred method to handle it, as opposed to a static route or as opposed to jamming it into EIGRP. All right, so we're on Santa Rosa 01. Let's save our config just in case here. Okay, so the next attribute that we're going to look at is local preference. All right, so what we're going to do now is we're going to go ahead and we're going to set the local preference, right? And so basically what we're going to be saying with local preference is, I want this, right? If we're taking a look at the International Travel Agency now, I've got two paths out of my enterprise. So the first path is via an OC12. The second path out of our network is via an OC3, right? So this is kind of an obvious scenario that we want our traffic utilizing our OC12, and only if there's a failure of this OC12 link do we want to use AT&T and the OC3, right? So how do we tell the International Travel Agency, right, these iBGP peers here, how are they going to figure out, okay, well, I'm going to send routes out, and I want them to go out of the enterprise via router 6, Santa Rosa 01. Well, the way that we do that is with local preference. So let's go ahead and set that up. We'll go from privilege exec to global config, and I need to have a route map, right? So I'm going to say route map, and we're going to call this one pri for primary, permit 10. And what am I going to set? I want to set my local preference. So if we take a look at the local preference values, you can see that the values range from 0 to 4.2 billion. So it's a 32-bit value that we can set here. Now with local preference, higher is better, right? We want a higher local preference on the Santa Rosa 01 side. We want to use that Sprint OC12. So I'm going to say the preference is going to be 900. Right? We'll just pick an arbitrary high number here, and you want it to be higher than 100 because the default local preference is 100. So we're going to say set local preference to 900. Okay, now we need to apply this to our neighbor. Now the key here is, and we'll go router, whoops, say router BGP 555. The key is that when we make this application, we're actually not applying it to our IBGP peer. We're going to be applying this to our service provider peering, right? So I would say neighbor 192.168.1. Make sure I get the right address here. .5 route map primary in the inbound direction, right? Now this may seem odd that we're saying in because we're trying to control the outbound flow of traffic. But remember, we're saying that into this provider, this is going to be the preference into the Sprint autonomous system, right? So what is my preference or my local preference going to be? And let me make sure I get the IP address right. 192.168.1.5. So I'm saying that my preference into this neighbor 192.168.1.5, I'm setting it to 900. So if I say do show BGP IPv4 unicast, let's take a look now. So you can see I've got multiple paths to get to just about all of these prefixes, right? Some of them, my next hop is going to be the Sprint router, and then others, it's going to be the Santa Rosa 02 router. And it's the Santa Rosa 02 router right now because I need to get back on the Santa Rosa 02 and do the same thing, something very similar. So we're going to go to global config. I'm going to say route map, and we're going to call this SEC for secondary. So we're going to say route map secondary permit 10, and I'm going to set the local preference value over here to 500, right? Definitely lower than 900, so this would be the less preferred path. And then I need to do the same thing that I did before on Santa Rosa 01, router BGP 555. Now again, I'm not setting it on the IBGP peering, I'm setting it with the service provider, because now what I'm saying is traffic going into that service provider is 192.168.1.1. I want to apply the route map secondary in the inbound direction. So if I say do show BGP IPv4 unicast, let's see what we've got here. Let me say do show run section BGP. Let's make sure we don't have any mistakes here. So we've got that right, and I may need to do a quick reconfiguration. Do clear IPBG BGP star. We'll do out and see if that suffices. All right, so that looks good. Let's take a look at our unicast. A little better. Let's go back to Santa Rosa 01, and I'm going to do clear IP BGP star out as well. And then we'll rerun the show BGP IPv4 unicast. So as you can see, we've still got the default local pref values. I'm hoping I don't have to do clear IP BGP star. Let's go ahead and I'm just going to reset the adjacencies on both sides. Do clear IP BGP star. And again, this is highly disruptive and definitely something you would not want to do in the middle of the working day. This could be a resume generating event. All right, so that looks better. So my local preferences have updated here. Let's scoot back over to Santa Rosa 01 and let's see what we've got. All right, so now we're still waiting for things to converge, and this could take a couple seconds here because remember, we're dealing with our Sprint service provider connection, the AT&T service provider connection, and then ultimately those guys are peering through that Verizon connection. So we've got the local preference values look great, right? 900 on Santa Rosa 01 side, and then 500 on the Santa Rosa 02 side. Now we just need things to settle down with our neighbors. And that's exactly what we're looking for right there, right? This is fantastic. So the local preference change has taken effect. So now, and I'm on Santa Rosa 02 here, right? You can see I'm on Santa Rosa 02. So on Santa Rosa 02, which is down here, to get to the 10.111, it shows me that my next hop is 172.16.64.1, because again, it has a higher local preference. Now, let's take a look at the 10.222. So the valid and best path, which is an BGP learned path to get to 10.222. So here is 10.222. Remember before, I'm directly connected to this interface. So this is definitely the shortest way to go. However, the local preference value has been set to 900. So locally, inside the International Travel Agency autonomous system, I'm telling everybody in here, all traffic is to come to the OC12, right? Because take a look, even the AS path, this is clearly a longer AS path, right? I'm going through 2015 Sprint, through Verizon, to then finally get to that AT&T destination. Whereas I could, right, just simply run right up here to this AT&T destination. Now, our local preference is set up so that we're matching all routes, right? And you could come up with a more elaborate route map that says, for destinations that are customers that I know are hanging off, right, for customers out here, for that route map, set the local preference to go this way. And for customers that are hanging off of here, right, set the route map to send the local preference for those routes this way. However, in the scenario that we have, right, this is, again, just showing you that you can manipulate the local preference to use my primary path, and then we just kind of have this guy as our standby secondary path, okay? And you can see here that the lower local preference value, even though the AS path is shorter, is not being selected because local preference is evaluated as a BGP path attribute before AS path. Okay, so now I have all my traffic flowing out my OC12. So let me go ahead and clear my screen here. We'll come back into the window. So let's go over to Santa Rosa 01 and see what he's reporting, because it should be up to date now. And he's actually seen only the local preferences of 900. He's not seeing the multiple paths here. So we want him to see the multiple paths, because in case of a failure, and why is he not seeing the multiple paths? Let me come over to Sprint here real quick and say show IP BGP. So it appears that Sprint is seeing everything. And AT&T show BGP IPv4 unicast. All right, however, he's seeing it as two different directions. So we're going to go ahead and on Santa Rosa 01, do show IP interface brief. Make sure all the interfaces are up. So we're up. We're still just seeing do show BGP IPv4 unicast. So we're still only seeing the one path, and we're not jumping out to 7018. Let me check Santa Rosa 02 again. So Santa Rosa 02's got the right information. So here's what we're going to do. We're going to fail the link on Santa Rosa 01. And before I do that, let me go ahead on Santa Rosa 02. I'm going to start a ping. So first we're going to take a look. Well, let's confirm that this is actually correct. So if I say do ping and IP, my target address is going to be the 10.2.2.2, right? And that's basically, I'm going right here. So from router 2, I'm going right to the loopback address here. But we're going to see that that's not the direction it's going to travel. Datagram size is good. Time in seconds. Extended commands. So source interface will be my loopback 0 interface, and then we want the record pattern. All right, so let's see what path, and these now with the extended ping that we're doing here with the record option, it's showing the outgoing interfaces. So we'll take a look here. So the first outgoing interface, sourcing the ping from the loopback address here, you would think it would go this direction, but we've got the local preference set, so it's not going to go that way. The first outgoing interface is that interface, so the ping comes here. The next outgoing interface is the .6 coming this way. Then it goes out the .2, the 5050.2 into the Verizon cloud. It comes out the 7071, and then it goes to the 10222. Now that outbound return goes to the 192.168.1 and then here, right? You can see that it goes to the 192.168.1 on the return. So what do we have? We've basically created a scenario of asymmetric routing, which means it's going out this interface this way through Verizon and then back down here. What it should be doing, let me see if I can change my color here. Let me do control. What it should be doing, I'm just trying to get a different color. All right, hopefully that'll be the color here. So what it should be doing, and it should be going out this direction to the loopback and then coming back around the same way. Now, asymmetric routing is not necessarily a bad thing. However, if we had firewalls sitting here, right, and we were active on this side and passive on this side, and these are stateful firewalls, and let's say that the traffic was pinging out from this direction, right? Or coming this direction, right? If this is the active guy, he's coming out this direction. I don't want it to come up here and then try to come back through that firewall. Because this firewall here, the secondary firewall, if these are stateful firewalls, which 99.9% of the firewalls today are, he is not going to have that conversation that was initiated over here. In this case, asymmetric routing is very bad, right? Because it comes all the way around and hits this firewall, and then this firewall says, I have no record of that conversation. That conversation is going to be dropped, right? So, let's clear the screen here. All right, so we have asymmetric routing right now because we're controlling the outbound flow of traffic. What we're not controlling is the inbound flow of traffic. So right now, let me go back over to Santa Rosa 01 and see if it's still, yeah, he's still not cooperating. All right, so if I were to go into interface serial 000 on Santa Rosa 01 and say shut, let's take a look at Santa Rosa 02, right? So now this interface here is down, right? We set the local preference to send all traffic this direction. What does Santa Rosa 02 see? Do show BGP IPv4 unicast. He still sees his legitimate routes with a local preference of 500. The ones with 900 are gone because, again, that interface has gone down. So the local preference, which is now in effect, is the 500 with my peering over to AT&T. So if I were to say do ping, 10.2.2.2, and I'll use the source of my loopback 0 interface, I can still get there. What if I do the extended ping now from here? So do ping IP 10.2.2.2, and we're going to do the extended command, source interface, loopback 0. Need the record pattern. All right, so now where does it go? Much shorter, right? It goes to 192.168.1.2, so it is going this direction now. It hits the loopback, and then it comes back out of AT&T and right back into me, right? So it basically sources and starts here, goes up to the loopback, and comes right back down. Now, this works because this path over here is down. Let's take a look at Santa Rosa 01. And we're going to say do show BGP IPv4. So you can see Santa Rosa 01 now is learning from its IBGP peering with Santa Rosa 02. So he also has the backup path, right? Because this is what we want. Just because traffic here has gone down, right? We don't want to completely take this router out of service. Because think about it. If we were set up here, and let's say these are our distro routers, right? If I had distro routers here and we're running EIGRP internally between these guys in a bow tie config, EIGRP may have this as the preferred path, right? And it would. If this was EIGRP in here, this would be my preferred path because, again, I'm trying to send all my traffic to the OC12. So I just need to get the traffic to this router to send it this direction, right? Now, when might that change? Well, if this interface goes down, if traffic is still coming here, I don't want it to then not be able to go this direction and take this out of service. We would bring it up and then it would shoot across this path. Or, right, I could do something else where EIGRP would change the delay of the route, possibly, right? But I want to make sure that if traffic shows up here, it knows how to get to the outbound out of the enterprise, which is going to be that direction, right? So we still want the traffic to go that way. And so that's why over here we've got the local preference of 500 now being seen. So let's go ahead, let's bring up, and let me clear this out here real quick. Let's bring up that interface that we took down before. We'll say no shut. So now my peering is back up with Sprint. And you can see the adjacency just came back up there. So do show run section BGP. Let's see what we've got here. Route map primary inbound, so we're good. So now if I say do show BGP IPv4 unicast, right, you can see that I'm seeing the primary routes, right? So or I should say the primary path. And my primary path is always going to be out to the Sprint network. So let's go to router 2. Let's see what he sees. Do show BGP IPv4 unicast. So again, he's seeing both paths here. So let's go ahead and do something. Let's see how quickly does the local preference make the switch. So if I say do ping 10.2.2.2, now we know that the ping is going out the more preferred path, which is going to be out router 6 through the Sprint cloud to Verizon, then into AT&T. So we're going to put a big, oh, and I actually need to source that. The source is going to be loopback 0. All right, so my pings are working off of Santa Rosa 02. But remember, they're going this direction right now. Right, they're coming up here, and then they're coming back down to me. Because we're controlling the outbound path, we're not controlling the inbound flow of traffic. So from AT&T's perspective, hey, what's the quickest way for me to get here? Boom, it's my directly connected link. And so this is working in the outbound direction. So let's do this again over here on Santa Rosa 01. I'm going to hit shut, and then I'm going to flip back over, and let's see how quickly traffic is able to redirect. So we should only drop about one ping. Yep, and there it was. So Control-Shift-6. So that was it. Now, if you're asking me, that's pretty good, right? So this path goes down, right? For whatever reason, Sprint has a problem, and look at how quickly the outbound traffic made the adjustment to say, hey, I'm going to continue flowing. So we're probably about 2 seconds there, right? And then immediately the traffic starts flowing again. So if I were to say do show BGP IPv4 unicast on Santa Rosa 02, my local preference is good. My next hop is 192.168.1.1. Let's take a look over here at Santa Rosa 01 and say do show BGP IPv4 unicast. And there you go. He's now picking up those local preferences of 500, right? And he knows that his next hop is 172.16.32.1. That's router 7. Now, do we have the same problem here? We've got the interfaces down. If I were to say do ping, and let's take a look. We'll do an extended ping. I'm going to go to 10.1.1.1. Extended commands, yep. Loopback 0. Do we have the same problem now in the opposite direction? Well, we won't because the interface is down, but let's see what it looks like here. Right? So where does it go? It goes out the serial 010 interface over to router 7, you know, Santa Rosa 02. He sends it up to AT&T, who throws it out his outbound interface into Verizon. Verizon sends it down to the 10.1.1.1, and then it works its way back. And it does this because, remember, again, this interface right now is down. So it's not going to loop. If that interface were up and this was my preferred path going that way, we would have the exact same problem. So let's go ahead and say no shut. We're going to bring that interface up. Let me clear that layer. All right, so now when I say do show BGP IPv4 unicast, you can see that we're seeing our paths with a local preference of 900 going out to Sprint. So now we've achieved the outbound goal, right? And what was our goal? To get all traffic to transit from inside the enterprise out up into the Sprint cloud, because we want to use this OC12 as our primary. And this is going to be the secondary path with the OC3. However, what did we see? Right now, traffic from Santa Rosa 02, who's doing what he's supposed to do, and would be sending traffic that way. The problem is that traffic is going to loop if it comes over here to AT&T, because AT&T on the inbound says, nope, this is how I'm going to go, because that's the quickest way for me. And same thing, traffic that showed up over here would come this way, right, if it was trying to get to the loopback address on router 6. So now we need to manipulate the inbound traffic. So how can we do that? Well, there's two primary ways to do that. The first is to use the MED, right? The multi-exit discriminator. The problem with the MED, manipulating the MED, and that's why we've got multiple autonomous systems here, right? 701, 2050, and 7018, is what you're going to see is that manipulating the MED works, but only to the directly connected autonomous system. It is not a value that gets passed from autonomous system to autonomous system like the AS path does. So again, the MED value is an optional non-transitive. And that's what, and the key there is non-transitive. So I can share it from the International Travel Agency. I can set that value and set it up over, set the value on the provider side and share it, and it'll work here, but it will not get passed to other autonomous systems. So let's go ahead and take a look at that. So let me clear that out. All right, so let's go ahead and we're going to manipulate the MED value now to make sure that we can control, or to try to control in this scenario, to try to control the inbound, and I apologize, I am setting it on the Santa Rosa 01 router. It's going to be set on the peering with my provider router. So on Santa Rosa 01, and again, we're going to do it the same way we did with local preference. We're going to use a route map. So I'm going to say route map, and we're just going to call this, and we can't use the same name, we did primary. So I'll just say med pri for med primary. So route map med primary permit 10, and then we're going to do the same thing. We're going to set the metric. Now, with the metric, the key here is lower is better. Again, with local preference, higher was better. With the metric, lower is better. So I say set metric, and I'm going to go ahead and set a metric value of, we'll just do 20. So set metric 20. Then I'm going to go into my BGP config, so router BGP 555, and I'm going to do this with my neighbor peering with my service provider router, 192.168.1.5, and I'm going to apply the route map. Now this is going to be applied in the outbound direction, right? This is going to be applied in the outbound direction. So route map is med pri, because I want all traffic that's going out that interface on Santa Rosa 01. I want the service providers to send it back to me. So we'll say med pri outbound, right? I'm going to do a do clear IP BGP star, and we'll do out, but I'm going to do Santa Rosa 02 as well. So we're going to say route map, and we're going to call this med secondary, and I'm going to go ahead and say permit 10, set the metric. Now, lower is better, so I'm going to set this, and this is again a 32-bit value, so I'm going to set this to 100. Whoops, we'll set it to 100, right? And then we'll go router BGP 555, and my neighbor is 192.168.1.1, and we're going to say route map med secondary outbound. Do clear IP BGP star out. All right, so now with my directly connected adjacencies here, my peerings with the providers, the med value should be set. So if I were to come over here to Sprint and say show BGP IP v4 unicast, excuse me. All right. So what is my inbound coming from Sprint into the enterprise? What is my preferred path? So here it is right here. And you can see the inbound traffic coming back in, I prefer with this metric here of 20 to get to the loopback address of router Santa Rosa 02. My next hop is going to be Santa Rosa 01, right? So whereas before it was going out and not coming back the same way, take a look here. The med is set to 20, so now it says to get back to that loopback, I'm going to come back to Santa Rosa 01. Now, let's go take a look at, you'll notice that we don't see the med, or the metric of 100 here for the multi-exit discriminator. It never made its way from where I set it here over to Sprint. So let's go ahead and take a look at AT&T, and let's say show IP or show BGP IPv4 unicast. Now I've got the med value of 100 here, but did the metric get set over on the Sprint side? And the answer is no. And the reason, again, is it is a non-transitive attribute. So I set the med here. We set the med so that it would show as 100 here and as 20 here. But as you can see, I'm not seeing the med of 20. I'm seeing the med of 100. So what do we see up here? If we go take a look at the Juniper router, does he see, whoops, sorry, run show route. What does the Juniper router see as the preferred path back? So for the route to get to the loopback address of this router, of router Santa Rosa 02, and this is the most telling one here, right? It still says that the chosen path is through 70, 70, 72, which means I'm going to come here and then try to come down to get to that loopback address. I'm not going to roll back and come to 50, 50, 50, right? And it's the same thing. If I try to get to the loopback address of 10222 on AT&T, what is the preferred path? It's going to be coming out the 70, 70, 72. So once I hit AT&T, if I'm trying to get to the Santa Rosa 02 loopback address, whoops, sorry, the Verizon router is saying, yeah, no, to get there, you're going to go this direction. You're going to go that direction to get there, right? And so since he sees the med here as 100, he doesn't see a different value. Let's see what happens on Santa Rosa 02 when we now try to do the extended ping. So I'm going to say do ping 10.2.2.2, repeat count, extended options, yes, loopback, 0, and record. And let's see where we go. Do we still have asymmetric routing? So let's see. We go out the Verizon interface into the AT&T loopback address, and then where does AT&T take me? Sure enough, he takes me right back down into the International Travel Agency, AS5555, and then I hit the loopback address. And so this is the problem with MED. So in the exercise we did in 7.3, what did we have? We had that one router right here, and these guys were peered to a single autonomous system. And I apologize, I'm using my mouse. I need to switch over to my pen. So we were using the AS, the single AS. So in this use case, right, the MED works. It's not going to get passed on to anybody that sits behind me, but that's okay, because in order for traffic to get to me in the 7.3 exercise, it has to transit this autonomous system to whom I am directly multi-homed. So in this case, MED is a great option, right? And MED will work, even though it's optional, non-transitive. However, now that I'm peered, I'm single homed, but I'm peered to multiple service providers. I set the MED and tell this guy, yeah, the MED's 20. I set the MED and tell this guy the MED's 100. However, does that MED value get pushed up here and then pushed over here so that AT&T sees that the MED is actually 20 and the traffic's supposed to be here? No, because it is non-transitive. It is not going to be passed further than the immediate AS to which I am setting it in my peering, right? So 7.3's exercise, MED works great, and it's a great way to see that how the MED works. This is a great way to see that MED is not going to be the preferred approach when we are peered to multiple service providers, because MED is an optional, non-transitive attribute. Remember, we're setting the path attribute on the routes, on the NLRI, the network layer reachability information. When we set that non-transitive attribute, it goes up here to this AS 2050, and that is it. Because it's non-transitive, yeah, the path is going to get passed on, right? The NLRI gets passed on, but this MED attribute does not. And you can see that, again, when we're on Santa Rosa 02, or I'm sorry, when we're on AT&T, and I say show IPBGP, or show BGP IPv4 unicast, you can see that I don't see the metric of 20, do I? Because that is non-transitive. So then that begs the question, okay, well, if I'm single homed to multiple service providers in different autonomous systems, and I want to control my traffic coming back, how do I deal with that? And then that is where the AS path prepending comes in. Because remember, we're not looking at this, right? When we look at it in the outbound direction, it's different from when we look at it in the inbound direction. So AS path prepending says, I'm going to go ahead and I'm going to add my autonomous system number. You want to make sure you're always adding your autonomous system number when you're prepending. So I'm going to prepend my autonomous system number with the peering I have with my peer, so that one path looks more preferable than the other. And the key thing here is that the AS path is a mandatory, well-known mandatory attribute. And so mandatory means that it has to be present. Because again, what's the primary purpose of the AS path? It's loop prevention. That's why it's mandatory. So that means when I send out my updates, my BGP update messages in which the NLRI is located and the path attributes for that NLRI is located, that it is mandatory that as it goes from AS to AS, as it transits the different autonomous systems that are out there on the internet, that those values are mandatory and have to be attached to the NLRI. And so this is going to be sort of your best practice use case to control the inbound traffic coming into your enterprise. So let's go ahead and set that up. So the first thing that we want to do is we want to get rid of the med statements, right? We're going to get rid of the route maps that we had for med, because we don't need those guys. Because again, we're home to multiple service providers. Even though we are single home to them, it's still different autonomous systems. And so we did that. And did I skip right by it? I did. I was talking. Sometimes you're talking and you're not looking at what you're doing. So here we go. So no neighbors. So now the meds are out of there, right? The route maps, we can leave the route maps there, because as long as we don't apply them, it doesn't matter that they exist. But what we want to do now is we want to create a different route map. So I'm going to start on Santa Rosa 01. So here we are in Santa Rosa 01. I'm going to say not route server context. Oh, and I know why it did that. So we're going to exit out here. So I'm going to say route map, and we're going to call this AS path, path prepend. So ASPPP. And I'm going to permit 10, and I'm just simply going to say set AS path prepend. And now here's what I want to do. So on the primary router, I'm going to go ahead and prepend 3 instances of 64555. Right? So watch what happens now. So I'm going to go ahead and apply this to the peering I have with Sprint, my service provider. So router BGP 555, or actually, I apologize. I typed in the EIGRP one there. So let's do no set AS path prepend with that, and let's do this. All right, so let's say do show route map, and let's get this in here correctly. So where's my route map for 555? Where is it at? I'm not seeing it here. AS path prepend, and let's see, did it not? Oh, let me get rid of the no. All right, so there we go. Now let's take a look at the route map. So we're prepending our autonomous system. So we're manipulating the AS path length, right? So let me go ahead and type router, let's see, do show run section BGP. Is the route map still applied? It is not. So we're going to say router BGP 555, and then I'm going to say neighbor 192.168.1, oops, 192.168.1.5. We're going to put another route map here. And remember, you can only have in one route map per direction. So this is our outbound, and this is going to be AS path prepend out. Right? So I say do clear do clear IP BGP star out. All right, and let's go ahead and do show run section BGP. So what does our BGP section look like? It looks like that. Do show route map AS path prepend. And so there you go. So we're prepending 3 instances of our BGP AS 555 to our AS path, right, in the outbound direction. So what we're doing is we're telling Sprint that you need to tell everybody that there are 3 additional 555 AS paths prepended to routes that are coming back into us. Routes that you're advertising of ours, how do they get back to us? There's going to be additional AS paths on there. So if I step over to Sprint and say show BGP IPv4 unicast, you can see the effect that this is having. So here is the loopback prefix for Santa Rosa 02, and take a look. Sprint is saying that the next hop 1.6, it's not just one AS, right? we've prepended 3 ASs onto the originating AS. The originating one's on the right-hand side, and we read these from right to left. So here's where I've prepended 555 3 times, right? So how many AS paths, what's the length of AS paths for this prefix via the next hop of Santa Rosa 01? There are 4 AS paths here. So why is it preferring the path out 50, 50, 51? So why is it that Sprint is saying, yeah, no, to get to the loopback address of Santa Rosa 02 at the International Travel Agency Autonomous System 555, you're going to go this way because guess what? How many AS paths are in the, or how many AS paths are there? Or how many ASs are there in the AS path? There are 3. So this AS path is shorter than this AS path. So you can see, and this is also transitive, right? It is a transitive attribute because Sprint sees it. So let me go up to Verizon. Let's take a look at the Verizon router. We'll sort of walk our path here up to Verizon. So what does Verizon see now? Is he picking up the, oh, I'm sorry, I now want to do, yeah, no, it should see, is Verizon picking up the path to the loopback? So he says out 70, 70, 70 because that is the path that he would go. Let's step over to AT&T and see, does AT&T pick it up? So AT&T is not picking up the AS path prepending yet. He still sees the better route to get to that 172.1632 as the path, or as the one that has the path with just one AS path. So let's go ahead and let's set this up over on Santa Rosa 02 now, because we want Santa Rosa 02 to look the worst. So again, same thing. So we're going to say route map, and what do we call this? AS path prepend, and permit 10, and we're going to say set AS path prepend. Now, since we want this guy to look worse, we're going to prepend 5 instances of our autonomous system onto paths that we're advertising to our eBGP neighbor, AT&T, so that when he passes this information along, it's going to get picked up throughout the internet. So now I'm going to say router BGP 555, and my neighbor is 192.168.1.1. We're going to apply the route map of AS path prepend in the outbound direction, and I'm going to say do clear IP BGP star out. All right. So let's walk over and see, does Sprint pick that up yet? So you can see, whereas before Sprint had multiple paths up here, right? You can see that Sprint is now reporting only the AS path that had the 3 prepends on it, and we may need to bump our peering here on the Sprint side. Do clear IP BGP star out. Whoops. All right, so let's clear our Sprint setup here. And so we'll kind of walk through here and clear these guys out. So clear IP BGP star out. And let's see what he sees now, and there you go. All right, so this is what we're looking for. So routes that are being advertised, right? So how many paths do we have here? 1, 2, 3, 4, 5, 6, right? And then we prepended 1, 2, 3, 4, 5, and then here's the 6th one, right? So AT&T over here for the loopback address still says come back to the next hop, which is that Santa Rosa 01 router, where what we wanted to do is we wanted to prefer the path that would come back through AT&T. So the question is, why is the AT&T path, even though they're tied here with AS path, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they're tied. So what we could do, right, is we could go back onto Santa Rosa 01. First, let's go back to this guy here, and let's see what he's showing. And there we go. So he is picking the prepending up. I just needed to bump the process on the Sprint and AT&T side. So to get to that loopback address, the Juniper router now says that the best way to get to me to come back is to go the right way, right? Because he sees 1, 2, 3, 4, 5, right? If he were to try to go the other way, how many paths? AS paths. 1, 2, 3, 4, 5, 6, 7. Right? So the challenge that we have here is when we set it to 3 intentionally on the Santa Rosa 01 side, when we look at AT&T sees multiple ways to get there. However, the AS path lengths are the same. So what we would ideally want to do is we want to change on Santa Rosa 01. We're going to go back in and we're going to say route map, AS path prepend, permit 10, and actually I guess we could just destroy the route map, but we'll say set AS path prepend to 555, 555. So we'll set it to 2. So if I were to say do show route map AS path prepend, now we're only prepending 2 instances of our AS, right? Which is going to make us more preferred than Santa Rosa 01 more preferred than Santa Rosa 02, and that should be across the board. So do clear IP BGP star out. And let's take a look at Sprint here. We'll say clear IP BGP star out. And then let's see what Sprint sees. So you see, Sprint is seeing that the AS path is only 3 now instead of 4. So if we worked our way over to AT&T, do clear, or sorry, just clear IP BGP star out, and then we say show BGP IPv4 unicast. And did it pick it up? It did. Yeah, so it did make the change, right? So now how many AS paths does it see going back if we wanted to come back to Santa Rosa, right? So this is telling it, yep, to get to 172.16.32, where do you want to go? AT&T is saying, yep, send it back to 70.70.71. So let's confirm. Let's take a look at the Juniper router to make sure. I want to make sure that the Juniper router is doing what it's supposed to do. So run show route. So here it is. The Juniper router says, in order to get back to the 172.16.32.1, I'm going to take the path that only has 4 ASs in the AS path as opposed to the alternative, and it's not showing, where is it at? Yeah, so it's not showing the multiple paths. Did I bump? Did we do a jump start? We did clear it here. And he was seeing it before, correct? Yeah, he did see it before. And maybe let's see if we're just not being patient enough here. So he only sees that one path, which is the correct path, and that's the path that we want him to see, but he should be seeing both. And just not installing the one that's going out, the 70.70.70.2 is the next hop via Gigi 001. Okay. And again, it may be that I'm just not being patient enough. We'll continue to move on. This is the desired output, but it should be seeing that less preferable path here, just not installing it into the routing table. All right, so we'll come back over to Santa Rosa 01, and what we want to do now is we want to test with an extended ping. Because remember, prior to this, before we were trying to control the inbound traffic coming into our enterprise, the traffic was looping. It was going in an asymmetric path. So let's see if the AS path has done what it's supposed to do. So we're going to do IP 10.2.2.2. So we're going to ping the loop back on AT&T, and we want extended options, loop back 0, and we want the record option. And so let's see the path that we're taking now. Is it doing what it's supposed to do? So we'll trace it out over here on this side. Whoops, Control Z, sorry. And edit, that's not what we wanted. Yeah, that's not what we want. Let's get rid of that guy. Give me the pin back here. There we go. All right, so and we definitely don't want that. So let's say edit, clear. And give me the pin. Okay, so we started our ping here. So what's the first outgoing interface? 172.16.1.2, so it goes this way. Then it goes to 1.6, which is out this way. Then it goes to 50.52 is outgoing interface. 70.70.71, it hits this address. And then the next outgoing interface is my response back, out 70.72, out 50.51, out 1.5, which is the Sprint IP, and then out 172.16.1 back to my destination. And so this is the behavior that we want. We want to use the AS path to prepend to, again, advertise out on the internet that this coming back in through Sprint to control our inbound return traffic, that's the direction we want it to go. And we only want it to go this way if that path goes down. So let's see what that looks like now. If I come over to Santa Rosa 01 and say interface, not fast Ethernet, serial 000, and we say shut. So it's going to tear that down. Let me come up to Sprint and now run the command. And now, which routes, and again, they're still good routes. We've prepended 5 instances of 555 onto the NLRI, right? However, just because we put 5 instances of the AS on there does not mean that it's not going to be used. It is going to be used as it is right now on the Sprint router. As you can see, it will be used because this link is down, and so the advertisement of the only prepending 2 instances of 555, we're not doing that anymore. So again, not only are we controlling the outbound flow of traffic now in a redundant fashion, we're controlling the inbound flow of traffic in a redundant fashion, because now all that traffic is simply just going to start coming in here. And with this link down, it's not going out this way anymore. Everything's going out here and everything's coming in here. So this is a very redundant setup that we've got here, where we're controlling the inbound and outbound flow of traffic even in the face of failures. So let's see what AT&T says. And sure enough, there it is. 1, 2, 3, 4, 5, 6, right? So the 5 prepends, and then the original on the far right-hand side, right? The originating AS for these 2 routes. Let's go up and take a look, and let's see what the Juniper router is doing here, if it's cooperating. Okay, so it is cooperating now, and you can see 1, 2, 3, 4, 5. There's my 5 prepends, and where does that prefix originate? Out of 555. How do I get there? 70, 70, 72 via GIGI 001. Because again, this path is gone. At that point, the route map that we configured here and applied to this adjacency, this router is no longer advertising that AS path prepend, because this path is gone. So we want the traffic to come back this way. Now we've achieved that. So let's go ahead, let's go back to, where are we at here? Santa Rosa 01, and we're going to say no shut, because let's say Sprint cleans things up. The link is going to come up. Our adjacency is going to reestablish while we're waiting. There we go. The BGP adjacency is back up. And so now the traffic should be flowing back to me. So let's go to Sprint and see what Sprint sees. And there it is. Sprint likes the path back into the enterprise. It only had 2 instances of 555 prepended. Let's see what AT&T sees. Sure enough, AT&T sees both paths. However, oh, I'm sorry. Yeah, I'm sorry. AT&T sees both paths. This is correct. I was looking at them the wrong way. And it sees the outgoing next hop as Verizon, not as the directly connected subnet. And finally, let's see if our Juniper counterpart here, what does he see? Exactly, the 2 prepends and the originator. So this is the more preferred route for the Juniper router as well. All right, so that's the AS path prepending. And so then to wrap things up here, we're going to talk about default routes. So when we look at Santa Rosa 01 and I say show IP route, you can see that we're picking up all kinds of BGP routes. So if I had my peering agreement with Sprint and I said, send me the full internet routing table, right? And I did the same thing over here with AT&T and said, send me the full internet routing table, we'd have over 550,000 routes coming into our enterprise, into the International Travel Agency here. Now, the benefit of that, and I'll clear this while I'm talking here, the benefit of that is that we would always ideally pick the best path, right? Because if we've got the full internet routing table, we know the best path because we have every route that's on the internet. If we were getting partial routes, and that's kind of what we're simulating here with these loopback addresses that I have on the Sprint side, on the AT&T side, and on the Verizon side. So you could think of it as maybe we're getting partial routes. Now, why would I want partial routes? Well, maybe I have a customer here that I want to try to get to, and I don't want to come through AT&T to do that. Or a better way, given our current setup, right, we've got everything going out this direction of our enterprise, everything coming back in this way, maybe the customer's over here. Maybe I want traffic to go out for that customer and that customer only to go out AT&T's cloud. I don't want to have to go through the Sprint cloud, through the Verizon cloud, then into the AT&T cloud, then to my customer. So in that case, if I'm getting partial routes, maybe that's an option. However, if I'm not concerned about that, if I'm confident that, you know what, my performance going out the Sprint cloud is just fine, if I fail over to the AT&T cloud, I'm just fine, maybe in my agreement with the providers, I say, you know what, just like OSPF, right, send me a default route. That's all I want. So I don't want partial routes. I don't want the full routing table, right? So I don't want to see all of these BGP routes. All I want to know is the default route. And I still want to be able to fail over. So all we'd have to do is in our peering agreement with Sprint, we would tell Sprint, you know what, just send me a default route. So I'm going to go ahead and say router BGP 2050. And we're going to say neighbor 192.168.1.6 default originate. And then I'm going to go over to AT&T, and I'm going to have AT&T do the same thing. We're going to go to global config, router BGP 7018, and I'm going to say neighbor 192.168.1.2 default originate. So let's go back, right? And again, we're not done yet. So let's go back because we're going to see what happens here. So the provider says, okay, well, I'm going to send you a default route. So I say show IP route, and I've talked long enough, hopefully the route is in here. And it's not yet. I may have to give it a kick. See Santa Rosa 02. Let me save my config while we're waiting. And I'll say show IP route. No, nothing yet. So I may have to force it. All right, let me go ahead and force it. So I'm just going to say do clear IP BGP star out on Sprint and do clear IP BGP star out on this side. So back to Santa Rosa 01. So now when I run this command, I should be getting a default route. And sure enough, I am. But what do you notice? I'm getting the default route, but then I'm still receiving the partial updates. So, and this is key because I'm almost positive in the exercise in Chapter 7 that we did, this is exactly the scenario that you ended up with. So I think it's great that I've got this default route, but if I only want the default route and I don't want partial updates, right? Because I don't want it crowding my routing table up for whatever reason. In order for me to get only the default route, I would tell the provider, you know what, make sure that I get the default route and only the default route. So how do we do that? We deal with that with what's called a distribute list. So in a distribute list just simply references an access list. So I'm going to say access list 1 permit, and I'm going to permit 0.0.0.0 the default route, right? And then I'm going to say access list 1 deny any. Okay, so if I say do show access list 1, that's what my access list looks like. I'm basically saying permit the default route and then deny everything else. So let's apply this. So I'm going to say router BGP, and we're at Sprint, so 2050. And we're going to say, neighbor 192.168.1.6 distribute list 1 out. Right? So do clear IP BGP star out. And let's roll back over to Santa Rosa 01. So that was the routing table before this change. What does it look like now? And did I do that distribute list in the right direction? Oh, you know what? Did I leave off? Let me go back over here to Sprint. I think maybe in my access list. No, that should be correct. Yeah, that distribute list should be correct. Let's make sure that I'm just not being impatient. No. Oh, I see. Sorry. I see what's going on. Yeah, it's correct. And I just looked here. So did you notice what changed? Take a look at the next hops. When I did the distribute list and I denied all other routes except the default, what happened? I apologize. I should have caught that earlier. So here, right? So here we are, and what's the next hop? The next hop is Sprint. You see that 192.168.1.5? That's where I did the show IP route. I made the change. We come back in. I pick the default up, but now I'm learning these via IBGP. I had just expected these to go away. So we need to do the same thing, complementary thing on the other side, right? Because I want to make sure that my outbound traffic is still transiting only the Sprint cloud. So let's go to Santa Rosa 02. We're going to do the same thing. And I'm going to say, go to global config, access list 1, permit 0.0.0.0, and then access list 1, deny any. We're going to go into our router, and I apologize, I'm on Santa Rosa. I guess we can leave that there on Santa Rosa 02. I thought I was on AT&T. So again, access list 1 permit 0.0.0.0, and then we're going to say access list 1 deny any. I'm glad I caught that before I went too far. So then we're going to go router BGP 7018, and I'm going to say neighbor 192.168.1.2 distribute list 1 out, and then we're going to say do clear IP BGP star. Oh, I said star. I wanted to do out, but this will definitely do. This is definitely going to set it. All right, so now we come over to Santa Rosa 01, and I type in show IP route. What does my routing table look like now? All I have is the default route, right? But again, that's really all I need, because the traffic from the local pref, if I say show BGP IPv4 unicast, is my local preference still set? It is, and that is the default out, right? So I'm actually applying the local preference value, right, the attribute, to this default route. So let me go ahead and go back over to Santa Rosa 02, and we're going to say show IP route. Let's see what Santa Rosa 02 sees. So he also sees a default route. However, where does he see that default route? It's via Santa Rosa 01. So when I say show BGP IPv4 unicast, in the BGP table, I have 2 default routes, right? However, I'm choosing this default route via Santa Rosa 01 because of a higher local preference. So we've really done quite a lot in this lab, and we've set up a really nice redundant configuration for the International Travel Agency here in this scenario, where we've got the next hop self is set up. So we know how to get to the next hops of eBGP learned routes that are coming into our iBGP peerings. We've got the local preference working for ourselves. So the local preference value is saying, I want all traffic exiting my enterprise to go out the Santa Rosa 01 router to take advantage of that OC12. If we fail over, it automatically fails over to the OC3. And when that happens, we looked at the MED and we saw why the MED doesn't work in this scenario. Because again, the multi-exit discriminator is a optional non-transitive attribute that I can share it with the AS directly next to me who I'm peering with, but it's not going to be transitive and then be passed along with the NLRI, right, the network layer reachability information. And the path attribute of the MED is not going to go up to Verizon and then back over to AT&T, and vice versa. Santa Rosa 02 sets the MED with AT&T. AT&T is not passing that MED to AS701 Verizon and then down to the Sprint AS2050 because it's non-transitive. So what's our solution? Well, we did AS path prepending, where we're telling the providers, right, and let me jump out to the Sprint router here, do show BGP IPv4 unicast, we're telling the providers, hey, prefer one path over the other. And in this case, the path we're preferring is where we prepended just 2 instances of our AS 555 to the NLRI. And did that make it all the way over to AT&T? Do show BGP IPv4 unicast. It certainly did. So how would I get to the loopback address of router 2? Well, I'm going where I've only prepended 2 instances of the AS, because again, it's shorter than where we've prepended 5. Do you see that? Right? So we now control the inbound flow of traffic as well as the outbound flow of traffic. So we're definitely taking advantage of that OC12. And then the last thing was that, you know what? We're okay getting default routes from the provider. I don't need a partial internet table. I don't need the full internet routing table. So just send me the default route, and let's see what that looks like. Here it is, right? That's my preferred path. Show BGP IPv4 unicast. Or I'm sorry, show IP route was what I wanted to see. Show IP route, and so there, completely cleaned up my routing table because I'm only taking in that default route, right? So now let's do one last thing. Let's go into global config. Let's go into interface serial 000, and let's make sure that this does what we want it to do. I'm going to go ahead and say shut. Before I do that, we're going to go ahead and do an extended ping here. So I'm going to say ping IP 10.2.2.2. Repeat count 5 is fine. I want extended options. Loopback 0 is the source. Record. Oh, sorry. Record. See if it does what it's supposed to do here. Now, we should see that this is going out over to the outbound. The outbound interface off of Santa Rosa 2, over to Santa Rosa 1, up to Sprint, to Verizon, down to AT&T, hits the destination, goes back to AT&T, back to Sprint, back to Santa Rosa 01, and then out Santa Rosa 01 over to Santa Rosa 02. So no asymmetric routing here, right? So this is doing exactly what we wanted to do. We've got the outbound flow controlled, the inbound flow controlled. So now I'm going to do an extended ping. I'm going to ping 10.2.2.2. I'm going to repeat a ridiculous amount of times. And then I'm going to source it from loopback 0. And sorry about that, loopback 0. All right, so the pinging is working great. No asymmetric routing. The outbound flow is controlled. The inbound flow is controlled. Let's test our failover here. So I'm going to come back over here to Santa Rosa 01. I'm going to say shut, and then quickly transition to Santa Rosa 02. What do we lose? About 4 seconds, maybe 3 seconds of traffic, and then take a look at that. Right back up and running, and we know that all traffic is now simply exiting on this side of our enterprise and returning on this side of our enterprise. Let's confirm that one last time. What does Sprint see? Do show BGP IPv4. Sprint says to get to the 10.2.2.2, where am I going? Yep, I'm going over to, and actually, there we go. Sorry about that. I wasn't there yet. I was looking for the 172.16.32. So we're sourcing our ping from here. So where's it going? Take a look at that. It just went ahead and inserted the correct route into the routing table, the correct prefix into the routing table, the AS path prepend, right? There's where we prepended 5. 1, 2, 3, 4, 5. And now this is the better path. So Sprint knows, you know what? This link is down over here now. So any traffic I get that's going to 172.16.32, maybe from this customer here, traffic's coming in, and it used to just go this way. Now when this customer's traffic comes in, it's going out that way, right? Let's see what AT&T sees. Do show BGP IPv4. Yep, AT&T made the change as well. So now this customer out here, when the traffic was coming in here to get to the loopback on Santa Rosa 02, it was going that way, but we've got this failure here. Our AS path prepending kicks in, and now AT&T says, you know what? We're just going to send it to my directly connected next hop, even though I've prepended 5 instances of my AS on there. And finally, let's see what our Juniper cohort is doing. Run show route. So what does he see to get there? He sees the prepended version of the AS path here. The one that only had 2 prepends is now gone, so he makes the change and installs that route into the routing table. And so we've got a fully redundant, fully functional enterprise for the International Travel Agency, leveraging AS path prepending. We're taking in a default route, and we're using the local preference. And so this wraps up really kind of, sort of the next step in what we were looking at in exercise 7.3. And I hope that this has cleared up any confusion that you might have had, and given you a better idea as to how you can set up your small to medium sized enterprise if you are single homed to multiple providers. And Lab 7.3 showed you how to do it if you are multi-homed to a single provider. And that's it. So I appreciate your time and appreciate you watching. And again, I hope that this was of value to you in talking about the BGP attributes that we looked at. So thanks for watching and enjoy what's left of your Memorial Day weekend.